A very impactful winter storm is on the way for many people across the United States, especially the eastern two-thirds of the United States. In this video, I'll be giving you an overview, especially for cities like DC, Baltimore, Philadelphia, up through the New York City corridor and the I-95 corridor, as those are just some of the major cities with high populations that will be impacted with this high impact storm. So let's get right into it. So this will be more of an informal video. I won't have any timestamps or any dividing things. This is mainly focusing on the Mid-Atlantic and Northeast corridor, but we will go over kind of the evolution of the storm so far right now. So here's current satellite. Okay, satellite goes east for the continental US, and what you can see here is this large scale system right here. Okay, very large scale. If you pay attention to the bottom left portion of your screen on satellite, you see this little spinny type of structure. This is where your Baja low is. Okay, this is where your low pressure system is, just recently coming ashore Mexico. Okay, tracking very south as we have a ridge building in the west, helping to really help this low dig down south and then eventually lift its way eastward. So currently right around here is where your low is, and it is a very it's not the most impressive looking low pressure. However, it has very wide access to moisture from the Gulf, Pacific, and Atlantic. Obviously right now most of it's coming from the Gulf and the Pacific, but soon it will tap into the Atlantic. So looking ahead of this low, you currently have this Baja low again moving on shore. You have lots of convection. You can see that convection in portions of the deep mid-south. This is where you're having lots of freezing rain, even some storms happening south of Houston. But mainly freezing rain, sleet, and some snow in the further north corridor. For example, if I were to highlight sectors, your stormier conditions or much further south, much further south, just given that we have such a cold high pressure in place. I'll go over that in a bit. Snowfall corridor is mainly through these areas up here right now, and then your ice all in between. Okay, your ice is all in between here, and eventually this will all begin to move east-northeastward. Okay, ahead of that we have a high pressure currently in place right around, hard to see on satellite, but you kind of see the snow cover here. You see some clear skies in the northeast, all because of the high pressure, but that's moving out. Okay, it's round right here, moving out, but it's a very strong one. Okay, 1040 millibars is around the strength of high pressure. We'll take a look at surface analysis. This is moving out. What it's doing though is creating a cold wedge. Okay, classic phenomenon known as cold air damming. That's when you have cold air, low level cold air, getting pushed up across mountains or higher elevations. In this case, it's the Appalachian Mountains, and so your kind of cold air damming is taking place. If I were to highlight an area right in here, okay, it's some deep cold air. Okay, you have cold air. You also have, with that cold air, you have some warming further into this pocket. The Tennessee River Valley is where you're getting some more warming, and that's why either to the west or east of your kind of viewing space is where you're getting more wintry weather. Further to the east, that's where your cold air is getting entrenched into the Carolinas, even into Georgia, including major cities like Atlanta, which is going to experience some freezing rain, which is a very complicated phenomenon. I'll see if I can pull that up on the fly later, the precipitation types, all to talk about. So we'll actually do that right in a bit. But this high pressure is going to fleet, but before it does, leaving very cold air in place, very cold antecedent air mass. I promise you, if this high pressure was just a typical little high and it was moving out, probably would mostly be rain for the 95 corridor. Same with the south, same with most portions of the mid-south, and especially down here in the deep south, if that high wasn't as strong. That's what's really driving this high pressure. Okay, it's very strong, almost record levels. So as this low continues to move east, you'll get another little cut. It's not really going to be a formidable low or a secondary low. It'll be, you could call it a secondary wave of low pressure that'll kind of take place in between the Arklatex, and that will eventually kind of head further east. Up here, a better track would be kind of like that. It will cut. Okay, it would cut, and so you'll see a coastal low transfer take place off the coast, and that'll take place. So you have a couple of low transfers. Okay, This versus Baja low, that's going to kind of drive through, get a little secondary motion, secondary wave of low pressure. This will get the storm to amplify, and then once it really starts intensifying, starts gaining latitude, you get a coastal transformation off the coast. Okay, if you didn't have that, it'd probably be again rain for the 95 coastal plain. You get the low, you're able to stop that mixing line, and you're able to get some snow, more snow and ice rather than just plain rain. So let's kind of pull up. We can pull up those precipitation types later. I'll kind of just describe it in this video. Let's kind of look at the upper levels, the mid levels we'll start off at. And so if we're looking here on earth.nullschool.net, you have these are the isobars. This is the way the wind is moving at 850 millibars, around 3,000 to 500 feet above our heads. It's mainly around 3,000 feet. Here, kind of going like this, and then kind of going downstream like that. Here you have a little kink right here. This is where your Baja low is, right here. Here, I'll use a different color. Baja low is right here, okay? But calling it Baja because it's coming off the Baja California coastline. And then here's your other kink. Here's kind of where your secondary low is trying to get going, okay? This is going to eventually go like that, okay? I was probably portraying it a little too far south, but it's going to go like something like that. Right here, I'll probably more like that, okay? It won't start gaining latitude until later, okay? And you could get some transferring further south, which could sag it even further south. That's some real-time observations we'll have to take a look at. And then eventually your coastal low will form somewhere out here, and depending on how close it gets to the coast is where that mixing line could get. Right now, best prospects show it checking somewhere like this, okay? And so you get your mixing line, which I'll highlight in a little kind of purple pinkish here. It'll be north of DC, north of Philadelphia, and likely something like that, okay? That's where your mixing line will probably be. Or here, if I actually had to draw a little better, it'd probably be something like that, okay? Something like that. It will likely be north of DC, Baltimore, and Philly, but New York City, it's a close call. We're going to be talking about that in this video. Okay, hold on, let's go back. So that's our 850s. Something else to note, we'll go up to 700 millibars, okay? This is closer to 5,000 plus, okay? This is above 5,000 feet in the atmosphere. You have this strong southwest flow. Here's your Baja low right here. Even prominent at 700 millibar low, 700 millibars, showing that it's a pretty strong system, whereas your previous low that was over here, kind of nowhere to be seen. That's why I kind of referring it as a secondary wave of low pressure, not an actual formidable low pressure system like this Baja low. But anyways, you do have this southwest kind of flow, okay, coming straight out the southwest. What does that do? As this is the not the jet streak, but jet streak is 700 millibars, and so this low, it's kind of going to track along this jet streak. And while it does, you get southwest winds. You have moisture here from the Gulf of Mexico, Gulf of America, whatever you want to call it. You get precipitation. Once it gets further here, and once you get that coastal low transfer, same southwest flow will help to throw back precipitation into that cold Ancina air mass. Okay, that's kind of your general setup over here. And what that also is this is a warm air. This is overrunning. Okay, this is an overrunning setup where you have high pressure. Okay, and sorry, I didn't mean it's not going to be really fleeting. Okay, it's going to be kind of retrograding further north and east, but it's relatively going to stay where it is. I mean, it's gonna go north and east, but it's relatively gonna be in the area, and that's why you're gonna keep that cold air damming and that prolonged ice and snow event. So here's your high pressure. Cold air, let's say, is entrenched through here. Your low right here. Okay, that's a one wonky looking low. We'll refer to the Baja low. This kind of comes through like here, through like this, and then you get your warm air advection with the southwesterly wind, and you get overrunning wherever those lines kind of, the cold air, warm air overlap. That's where you get your overrunning. Ice, snow, and rain. Mainly snow and ice. So that's your general overrunning setup. Kind of typical in El Nino patterns. I'm kind of El Nino, La Nina hybrid. It can happen in both. I'd say it tends to favor La Nina slightly. Here's your surface analysis. Okay, we love the surface analysis here. So we can come over here. Another thing is this is kind of like a banana low. Okay, you have kind of three low. It's one big low low. Banana high is what I like to call it, because it kind of looks like a banana. Okay, I mean, we can even, here, let's draw it in a little bit of yellow. There's your little banana right there. Okay, banana high pressure. Okay, you have three real triple dip highs right here. Okay, one over here, one over here, and one over here. One in Wisconsin, one in the Lake Erie. Wait, is this Lake Erie? Wait. Oh my gosh, am I forgetting my lakes? Okay, near Erie, Pennsylvania, and then the other one north of upstate New York. That's kind of where your high is. Okay, it's one big high though, and you can see how strong it is. I mean, zooming out, there's your cold front. It's entrenched into Florida. Okay, here's your high, and I mean, just to reference how cold it is, at my house over here in Philly, my weather station dipped to 8 degrees Fahrenheit this morning. 8 degrees, so it is some cold air. Okay, when I mean it. Okay, another little high right here. Overall, just strong high. Barrel cleaning zone way down here, and so here's your Baja low right here, and so this is gonna overrun. Okay, overrun. That's what's forcing that precip right now, and going to force it further to the east. So if we're looking at current observations, mesoscale analysis, okay, this is your 850 millibar analysis. I do want to note the warm nose. That's a very crucial part of this storm. Okay, here's your cut of cold air entrenched. Here it is. Okay, this is your high pressure right here. Really bring that cold. It's hard to see, but you see this little kink right here. If you can see it, there's a little kink. It'll become more defined over the next few hours. But this kink is that cold air damming. Okay, CAD. Okay, I'm gonna refer it to CAD. That's what you call it, CAD. So CAD is gonna be setting up, and so that's how you're forcing more ice and snow to prolong in portions of the Mid-Atlantic and Southeast. Here's your deep cold air behind the system. Okay, this is all ice. Okay, surface is extremely cold. Okay, that doesn't translate to the mid levels necessarily, even though the mid levels are cold, especially kind of in these areas, and up here. But it's really the surface, okay? And here is an example where the mid levels aren't as cold. Let's show that a little bit of an example of that. So this is 850s. Here, let me see if I can find a better example. It's going to be a little bit hard. So here, if we're going to surface, let's go to surface real quick. Okay, we'll see if we can kind of zoom in on sector. This is on the fly, so it's a little, kind of might be a little janky. So let me get to this sector. Here it is. Here's your, let's go surface. Okay, let's go surface observations. Look at these temperatures: 13 degrees, 12 degrees, 9 degrees, 5 degrees. Okay, Dallas, Fort Worth, experiencing some ice. Okay, it's cold, dude. It is really, really cold. And so it's cold. You mean even what do you call it? San Antonio could even end up with some ice towards the tail end of this event. Okay, 925s. Let's kind of do some line mapping. Here's your freezing mark at 925. This is kind of around 2,000 feet, I'd argue. Maybe 1,500 feet, in between 1,500 feet, 2,000 feet. There's your zero line, 850. Look at how much more kinked up it is. Okay, here's your 850 right here. Your freezing line. That's a few 100-mile difference, and that's important because basically what it tells me is, okay, more sleet in these areas. See these little pockets of precip? Here it's more freezing rain, and then anything south of this is likely just rain. Okay, so if we were to characterize, so that this would be sleet. Oh, I forgot exactly what you call it. So we'll just do SL. Freezing rain is ZR, and then your green is obviously just rain. Okay, that's how you're, and then if you want to go up to 700 millibars, which we can, can't see as well, but that freezing line is way further north. Okay, hold on, let me get to that black. It's even more up here. Okay, this is, or at least, yeah, right through here, and north of here. So in these areas where you're getting your snow. Okay, very, very intricate analysis is what you have to do with this, with kind of what's going on. Okay. And I mean, see all this green? That's all the moisture in the air. Okay, I mean, if we were going to look at precipitable water values, look at that moisture tab. 1 inch water here, right off the coast. This is where you're getting some of your storms here in southern Louisiana. It's some pretty impressive moisture, especially for winter. Okay, and this is just going to surge north with that southwesterly flow. It's going to help pick it up as the storm lifts east northeast. Okay, and so temperature advection. There's your warm air advection. Right here, all this these red colors, that's your warm air advections. Overruns the current cold air. That's how you get this precipitation to get forced out. This is also what's going to be changing many areas from snow to ice to even rain. Okay. Frontogenesis is another thing. Okay, if we're looking at frontogenesis, this is what's this is forcing. Okay, lift in the atmosphere. Here's your frontal genesis causing more heavier rates of precipitation. Okay, likely in the form of snow, sleet, or freezing rain. So, for now, that's honestly all I really care to talk about. We can probably also look at defluents. Don't know the best kind of thing to look at. Again, right on the fly with SPC mesoscale analysis. We can go down here to defluents. This kind of shows the picture. All this like fluid trappings kind of stretching of the atmosphere. That's what's forcing this lift. Okay, it's all lift that's really causing this. I'm really trying to see. You can see it line up here as well. So it's where you could be getting some more prolonged rates. Yeah, I think this is the best I can do. Upper air. Yeah, that's honestly the main stuff to look at. Okay, but it just shows you it's active up there. Okay, it really is. Okay, so yeah, that's current surface analysis. Okay, let's go to kind of forecasting part of this. Okay, off of the observations. Okay, so I'm already have this in the mid-Atlantic corridor, but we'll zoom out just a tad. And so this is ARRR currently, and so or RGEM. I think the RGEM has a really good handle on it. You know what? I think we are going to go to ARRR though, because RGEM's a little more aggressive with the snow in the mid-Atlantic. Or RGEM is. ARRR is kind of middle ground. NAM is a little warmer solution. So let's see if we can get back to 18Z. So here's your storm. Okay, honestly depicting it pretty well. A little more of this is sleet actually. Like in Nashville, there's actually some sleet going on. Okay, wait. So yeah, this is the current projection. Sorry, I was ahead. But Nashville, snow to sleet to freezing rain. But this is where the cold air is, okay? This originally looks like, I mean, this high is so strong. Many people are like, oh, this is like forecast earlier, because I know I didn't upload a video this whole week. Forecasts were thinking that this low would be suppressed, okay? It would stay south. I'm trying to use better colors here. It would stay south and kind of come off the North Carolina coast. That is why we had portions of Richmond getting into feet of snow. Okay, trended north, kind of started coming out here. Here again, I need to use better colors. Oh my gosh. All right, we'll use this like brown color-ish, maroon color. So then it came up here. That's why Philly, Baltimore looking like the hot spot. New York City, I mean, especially Philadelphia to DC was looking like a hot spot, 1 to 2 feet. Now it shifted even further north. I mean, now it's a Miller B setup. First, it'll just be classic southern slider overrunning event. Now you have your low kind of get cutting, and then your coastal transfer, so you're going to get mixing. So your jackpot is more towards central PA and just north of New York City. Okay, just north of NYC. So that's why this is such an interesting setup. Like, this would look like all snow, but you'll see why. So, cold air overspreads. There's snow starting to break out. This is 2 a.m. Eastern Standard Time. So, DC is starting to break out with some snow. Some heavy rates. Okay, it's going to be some very heavy snow. Okay, really given how cold this like overrunning is gonna be. I mean, this is some cold air. This is that warm nudge I was talking about. Okay, this is cold air damming. Okay, drawing this in blue here. That's your cold air damming. Okay, maybe black might be. Yeah, black. Well, looks to here. You know what? Let's do this freaking thick black line. Okay, here's your cold air damming. Okay, see this little warm nudge up in here? That's because of the low. Okay, it's because the low is kind of tracking in the general direction. Cold air on each side of it, wrapping behind it, and in front of it is the cold air damming from the high pressure that's retrograding slightly north and east. Okay, that's kind of your setup there. Raleigh, freezing rain. Richmond gets your snow burst, but quickly over to sleet and eventually freezing rain. So here's your snow. Starts to break out around Philly. Here, we'll see if we can zoom in just a bit. Philly starts breaking around 4 a.m. Okay, 4 a.m. And New York City gets into it around 7 a.m. Okay, here's your snow. Richmond starts to get over to some sleet. That's because you have warm air advection at the mid-levels. We'll get to that. Okay, but general radar progression. There's your snow. Washington, heavy snow right before the changeover, 9 a.m. Washington, these areas will still get a good thump of snow, okay? 2 a.m. to around 9 a.m. That's around 7 to 8 hours. I think it could be a little slightly more. Around 7 to 8 hours, closer to 8 hours, I say, for DC, for a thump of snow, okay? You could easily get a quick 5, 8, 6, 9 inches of snow in DC with this, okay? Especially, probably closer around 5, 8, around 7 inches, I'd say, off this thump. Okay, Baltimore comes in around 2, 3, starts to mix around 10, 11, same thing, okay? Maybe a little more than DC. DC gets a sleet around 10 a.m. Baltimore at around 11 a.m. Philadelphia, it's snowing. Okay, further north and east you go, even along 95, you should get a little more snow than the cities that are further south and west along the 95. 11 a.m., 12, 1, Philly starts to mix. Okay, Philly starts to mix. But you see that sleet line starts to slow down. Okay, I mean, it was going quick. Now it's starting to slow down. Okay, it's starting to slow down. Here you have some heavy snow. Okay, or sorry, heavy sleet in this black circled area. Heavy snow just north of it. Okay, New York, there's your snow. Okay, there's your snow for New York City. Purple sleet, pink is that freezing rain. You'll start to see that lift north. Okay, DC, it gets into some freezing rain. Same with Baltimore. There's your sleet kind of intruding New York City. Look how razor sharp that is. Look at that. I mean, that is pure. That is so sharp. There's your sleet line right there. Okay, it's going to be close. North portions of Bronx could probably be snow, while the rest of the boroughs are sleet at this time. It flirts around. You can see back to snow, back to sleet. Okay, stay sleet, and then maybe a little initial push of freezing rain. But it's gonna be interesting. Rain gets close to 95 too. I think that they're overdoing this a little bit. I think it's freezing rain from DC, Baltimore through Philadelphia, and New York City could get on some as well. But that's your general progression. For most of these cities, it's predominantly snow, especially for Philly, NYC. Okay, predominantly snow, then solid sleet, then a touch of freezing rain at the end. Now, why are we getting this warm air intrusion? Okay, I mean, I already said the high is retreating ever so slightly. The low is cutting. You get a coastal transfer that kind of hugs the coast. Miller B, the transfer of energy, causes the low to jump, causes the sleet line, mix line to jump. Okay, but why is it doing this if the surface temperatures are so cold? Let's talk about it. So if we were to go towards, I don't know, 2 meter temperature. How do we do 2 meter temperature right here? Okay, here, I need some water real quick. Hold on. Mouth is getting very dry. Don't know if you guys heard that, but alright, back. So DC, this is 4 a.m. Okay, we can go back to like 1 a.m. DC, 19 degrees. Baltimore, roughly 17 degrees. Philly, roughly 16, 14 degrees just north. New York City, 15, 13 degrees. Okay, and then Boston up here, freaking single digits, bro. It's cold. Surface temperatures have no problem. Okay, surface temperatures have absolutely no problem with staying below freezing. Okay, here's your, again, another really nice representation of cold air damming. Okay, look at that. That's your freezing line that I just drew in black. Okay, look at that warm pocket. Okay, this is really screwing people up if you're in this area. Kind of feel bad, but there's your warm pocket. Here's your cold air damming. Oh my gosh, wait, I can just go back. Okay, and here's your cold air damming right through here. Okay, very impressive. So either way, there's your freezing line. So if we were to, here, let's kind of match up with radar. Okay, let's kind of match up with radar. I want to get base reflectivity. Kind of zoom in here. Or precip type, sorry. Precip type. We'll go like right here, okay? Or we'll go for, let's start with DC and Baltimore. Okay, DC and Baltimore. It's sleet. Okay, let's check the temperatures out then. Let's take the temperatures out. 2 meters. Oh, 19, 20 degrees. 18, 19 degrees. Why is it sleet? It's below 20 degrees. Okay, well, you can't just look at surface temperatures, can you? Now let's go to 925. Okay, let's go to 925. DC, oh, -7 Celsius. Oh, I don't know if I can get this in a Fahrenheit. Either way, let's just say it's below freezing, right? It's below freezing. Baltimore, -7, -8. Let's go a little higher up. Let's go 850. Okay, let's go 850. Oh, -4, -5. It's still below freezing. -7, -8. Okay. 700 millibars. It's a little interesting now. -0.4 Celsius in Washington, D.C. right here. Baltimore, -1 Celsius. That is very marginal. And looks like I can't see that warm nose here, but here, let's go right back to the precipitation. Okay, I'm going to show you how razor sharp this is. Washington D.C. sounding. We'll do sounding right now. Okay, let's do some analysis on the Washington D.C. sounding right now. 11 a.m. Okay, what is that I see? Okay, what is that? Let me kind of circle it right here. Okay, we'll use blue. Oh, okay, now I kind of have to shorten that right here. That's a warm, or here, you know, since a warm nose, I should use some warm colors. There's your warm nose right there. Warm nose between 700 millibars and 850 millibars. That's why we didn't see, you know. That's why I was kind of close, but closer to 700 millibars. Now, we can see that through this too. I like this. This is very neat from Aguacero. Look at the temperatures. You can see it. Negative 0.9 Celsius, 0.1, and there it goes above. That's above freezing. 2 degrees Celsius above freezing. But that's enough, and it's prolonged enough. So where, here, let's kind of do some markage. Around right here. Oh my gosh, I need to get the better color. Okay, right here-ish. And then right here-ish. Okay. Above this blue line, it's snow. Okay, it's snow. In between these lines, believe it or not, it's actually rain in between. It's enough space where the snowflakes are melting into raindrops. Okay, because it's above freezing in that little layer. Shallow layer. And then below that, you have sleet. Okay. You have sleet below that. Okay. Also, you can call it, it's meteorology IP, which is for ice pellets. Okay. Shallow warm layer, deeper, so you have a very deep cold layer above, obviously. Okay, that's your snow, that's where your dendritic growth zone is. There's snowflakes. Very shallow warm layer. Melts into raindrops, though. And then a nice deeper cold layer below, able to refreeze into sleet pellets for DC. And this would go for Baltimore as well. It's going to go towards freezing rain now. How we take a freezing rain sounding, okay? How does this look? So, precipitation type. Snow, cold, stays below freezing the whole way through. Sleet, snow, shallow warm layer, melts raindrops, deeper cold layer, below that warm layer, able to refreeze sleet pellets. And here you have freezing rain. By the way, this 0 is 0 Celsius, so freezing. Here's freezing rain, okay? Do the same thing. Let's kind of divvy up the layers, okay? 700. So whenever it goes to the right of this 0, there's this line. It's kind of hard to see, but there's your 0 line. Excuse me. And so that 0 line kind of shows where your freezing line. So 0 line is where your freezing line is, technically. Your freezing temperature is in the common atmosphere, okay? First we'll draw that line, and then we'll draw this pink line right here. Is where it dips back. This is, if you know, this is a little more wider, okay? And so, above this, same thing, snow. Snow above this. Between, same thing, rain. Below this, rain as well. Or, technically, do a nice little ZR. Freezing rain. Now, with freezing rain, you have same cold layer, snow. You have a thicker, deeper, warm layer, though. Okay, this goes, last one was 700, 850. This is 700, almost to 925. This is 225 millibars. That is a deep, warm layer. Okay. See, max temps, it might negative, oh, gets up to 5 Celsius. That's warm. That's pretty warm, okay? That's 38, mid up 30s, okay? Almost, probably will touch the lower 40s, okay? You can also see, best guess, this says sleet. This is actually freezing rain, though. Why? Because, first of all, your warm layer above is thicker than your shallow cold layer at the ground, okay? This is where meteorology comes over modelology. They're 28 degrees, though. Your surface temperature is at freezing. And so you get rain, regular rain, that when it hits the surface, it freezes into a glaze of ice, which is very dangerous for roads. Because, first of all, you can't really see it on roads. Second of all, it's like an ice rink out there. Okay, and so we can see if we can get a better example, because this is when it like just turns freezing rain. We'll see if we can get one like right here. See who does the same thing. And yeah, I mean here too. Okay, like that is a warm layer. Okay, doesn't have enough time to refreeze. Okay, for example, Richmond. I'm gonna see if I can get a more signature. That's why it's a little bit battle zone between Washington and Philly with sleet and freezing rain. Richmond, I'm gonna see if we can. Okay, there's a pretty good one too. Look how warm it gets. 8 Celsius. Okay, 8.1 Celsius. Well, temperatures at surface are 25. That's freezing rain right there. That's the like classic sounding. But even there in DC, Baltimore could possibly get into some freezing rain. And then same for Philly. Okay, same for Philly. Just delay everything by like an hour or two. Okay, and New York City it gets interesting. Okay, let's do a little New York City sounding. I want to do something in New York City. Okay, let's do it like right there, kind of in the heart of NYC. Okay, this is interesting right here. Because you don't really, technically, you have a warm nose, okay? It's right here. It's right here's your warm nose, okay? But you see that how the 0C line is right here? It like touches it, okay? And if we were to kind of go through, look how close it gets. Look at that. 0, 0. It's like 0.5, 0.3, 0.2. Look at that, 0.1. It's close. And so, here, let's see if we can go one more frame. Here, for example, goes above freezing. 0.2, 0.3, 0.1. It's that close. That would be sleet. You can see it here too, sleet. Just by being 0.3 degrees Celsius above freezing for a short period, for a little layer. Now, I will say, if you have heavy enough rates, if you're moist, which you are here, whoops, that was a terrible circle. You're moist here. If you have heavy enough rates, that can cause it to crash, and you can push that sleet line further south. That applies for all cities, especially New York City, which is really on the brink. Okay, not all cities. I meant like DC, Baltimore, Philly, but especially New York City. Okay, each city further north and east, higher chance. But yeah, and then Boston, all snow for you guys up there. Sorry, I spent a lot of time on this. I want to get to it. But just to show everything, we can do total. I like how the ARRR showing everything. We can do total snowfall, Kuchera, to account for ratios. DC 6, 7 inches. Baltimore almost up to 8. Our area, Philly 8, 9 inches. New York City 10, 11 inches. And Boston, jackpot, just south. I mean, well, this doesn't go fully. There you go, 21. That like that 21. That's some snow there, okay? Do think it's I bet. So I'd say Washington, D.C. 6 to 8 inches. Philly, Wilmington, these areas, Trenton, probably 8, 9 inches. And then New York City could get up to a foot, honestly. Okay, maybe just under, just shy. It's gonna be interesting to see how that goes. Okay, model ratio would probably work good too. This one's a little more aggressive, 10, 11. Widespread. Freezing rain, though. Freezing rain is going to be a little bit of an issue. I do think it's overdone here. Actually, no, I don't think it's overdone. I think pretty solid. Quarter inch. I'd say it stays under a quarter inch for even DC, I'd say. But 1/10 of an inch to maybe just below a quarter of an inch, but above 1/10 of an inch is possible for DC. Baltimore around 1/10 of an inch. Philly could get up to 1/10 of an inch. Okay, it's going to be close, okay? Freezing rain will be an issue, okay? It makes it even worse. That's why your snow totals have gone down the last few days, because you're getting more mixing. Sleet will be impressive, too. I mean, New York City on the ARRR 1.5 inches, Philly 2.5, Baltimore 2.5, DC 2.5-ish, okay? So that would add to that snow total, okay? But since the ratios are 3 to 1, with sleet 3 to 1, it's going to be different. So we're also looking at ratios. Okay, I don't know if I can get ratios here. Kind of really lagging this behind, but it's fine. Precipitation ratio. So snowfall ratios. Okay, I do want to talk about some snowfall ratios. Okay, it's going to be 15 to 20 to 1 for portions of DC to New York City. Okay, closer 20 to 1 or higher when you get closer to Philly, New York City especially. Baltimore, DC, closer to 15 to 1. Probably maybe up to 18 to 1. So you're going to start out with dry, fluffy snow that accumulates rapidly, gets heavier and wet, and then you get over to your sleet, makes everything feel like concrete, and then add another glaze of freezing rain on top, and that just makes it terrible. Okay, that's basically your little wintry cake. That's the come. So yeah, it's either way, very, very, very major winter storm on the way for these areas. Polar Wx, okay, that was kind of weird. We'll just take a separate tab. Here's your national blend, 72 hours. I do think it's a little overdone, and I'm going to circle which areas. I think it's overdone in these areas right here, I'd say. Overdone just with some mixing. besides that, good agreement, I'd say. But yeah, I just want to show that real quick. And then when for example, we can kind of take this through. This is the HRDPS. Okay, took it too fast. Here's Washington. Started out. Look at the settings. Starting out snow. It's 22 is the highest your warm nose would get. I mean, that's pretty nice. You're getting some snow there. Okay, 21. You're getting some snow there. 21. And so we continue though. You see that it starts warming. Look at that. 25, 26. Okay, it's getting closer to this pink line. That's your freezing line. Let's go to 8 a.m. Even closer. Look at that. 29 degrees. Edging at 10 a.m. And there you have your warm nose right there. 32. Could still be sleet and snow, but by 11 a.m. 31, 32. Look, it stays close. This could be something too as well. This is underrated. Okay, I feel like just this would be like extremely intricate details, but you have your first warm nose up here is closer to 700 millibars than it is to 800. Then you get a pivot to 800 right here that you'll start to see kind of pop out a little bit, and then 700 pop out again. Watch, 700. There's your 700 nose right there. Retrograde back, just a tad. 850s takes over, and then you get a retrogradation. Between that pivot right there, that could spare you an hour or two to keep mixing with some snow and sleet before going to fully sleet and then freezing rain. Okay, and for example, this right here, this is freezing rain right here. Okay, this is warm. This is probably sleet and freezing rain. So yeah, this is your sounding forecast. Okay, this applies for most cities, for DC, Baltimore, including Philly, New York City again. Pretty tricky. Okay, it's gonna be tricky. New York City, tricky. Could get everything. Okay, New York. I don't know freezing rain as much. Sleet for sure, probably gonna mix with sleet, but how long can we hold that off? That's TBD. I'd say 3-4 o'clock's possible though. Okay, and then you flirt with that sleet line, maybe some freezing rain mixes. I'm gonna end you guys off with this: 6 to 10 inches for our area, maybe 1/10 of an inch of sleet, freezing rain, and an inch plus the sleet. That's what I'll say. Okay. And this is the map I'll leave you guys with. Winter storm warnings everywhere in the pink, winter weather advisories in the light purple, ice storm warnings in the darker purple. That's about it. Hope you guys enjoyed. I'll see you guys in the next one. Big one on the way.